Now we're going to start with Faraday's second law of electrolysis. This will be the last part of electrolysis. So this states that if the same quantity of electricity is passed through solutions of two different electrolytes, the number of mole of each substance deposited at the electrode is inversely proportional to the charge it carries. This is what we call Faraday's second law of electrolysis. Let's see the diagram. Let's say you have two different electrolytes. If you use copper 2 sulfate solution here, you are going to make use of a copper electrode. So let's say copper anode and a copper cathode. This is the first solution. You have another solution here. Let's make use of silver nitrate solution. Using silver electrode. This is silver. This is another silver. So this one will be anode. This is a cathode. That is what we have. If you like, you can use lead 2 nitrate. So this one will be lead like that. So look at the connection. You connect this one. Always remember it's positive. This one is a positive to positive. This is cell. That is battery. You have the ammeter here. Then you have rheostat. Then connected to the cathode. So this cathode is also connected to the anode here, like that. That's the diagram. Meaning, if you pass the same quantity of electricity, that's the condition. Let's see mathematically now. Mathematically, you know, copper will be deposited on the cathode, while silver will be deposited at the cathode here. That's what they are saying. So the number of moles of copper deposited at the cathode, let me say, let M1 be the mass of copper deposited. M2 to be mass of silver deposited. and let N1 be the number of mole of copper deposited. And remember, number of mole will be mass deposited is always mass of copper deposited all over atomic mass of copper. That is mass number all over atomic mass of copper. So let's denote it N1 to be equal to mass of copper is M1, atomic mass, let me call it A capital 1. So it will be M1 all over A1, where he means atomic mass of copper. Remember, copper is 63.5. Then again, remember, we have established that N1 is equal to mass of copper deposited all over atomic mass of copper, where N2, let N2 be equal to mass number of mole of silver deposited at the electric, and the formula is mass of silver deposited all over atomic mass or mass number, atomic mass of silver, atomic mass of silver. That is N2. So N2 now will now be call it mass of copper deposited is M2. So let's denote this one to be A2. That is the number of moles. Remember, A1 for copper is 63.5, and A2 atomic mass of silver is 108. Take note of that. This is 63.5. What difference here? 108. So let Q1 to be equal to charge on copper. You know it's plus 2. It's 2 plus 2. Because copper is written as a Cu2 plus. So the charge on copper is 2 plus. Q2 to represent charge on silver, which is plus 1. Remember, because silver is written as is plus 1. So the law now states that N1 is inverse proportional to charge 1. So we say N1 is equal to K all over Q1. So we call it equation 1. Also N2 is equal to K all over Q2, that of silver. So we call it equation 2. Always remember where K is a constant. Where K is a constant. So if you cross multiply here, you divide equation 1 divided by 2. Equation 1 divided by equation 2. So we have N1 all over N2 is equal to K all over Q1 divided by K all over Q2. So N1 all over N2 is equal to K all over Q1 times Q2 all over K. So K cancel K. Let me complete it here. So N1 all over N2 now is equal to, so we are left with Q2 all over Q1. So this is the formula for, that is a Faraday's second law of electrolysis. This is what the formula is. Now we've established that N1 all over N2 is equal to Q2 all over Q1. This is Faraday's law. But number of mole is equal to N1 all over E1, mass deposited all over atomic mass, while N2 is equal to M2 all over A2. So here N1 now becomes A1 all over M1 over this divided by M2. M2 all over A2 is equals to Q2 all over Q1. Q2 all over Q1. So this one is same thing as M1 all over A1 is equal times A2 all over M2 is equal to Q2 all over Q1. So this one can go, you can say M1 all over M2 here is equal to A1, so transfer. This one can go here, or times A2 all over A1 is equal to Q2 all over Q1. So M1 all over M2 now is equal to, this one can go here. So when you divide both sides by this, you have Q2 all over Q1 divided by A2 all over A1. So you have M1 all over M2 is equals to Q2 all over Q1, then times A1 all over A2. Let's take note of that. So we can further simplify this as M1 all over M2 is equals to, this is Q2 all over Q1, Q2, okay, let me use A1 over Q1, yes, A1 all over Q1 divided by A2 all over Q2. When you simplify this, you are going to get the same thing. Remember that this one will be A1 over Q1 times Q2 all over A2. We still the same thing as this. Q2 A1, Q2 A1, Q1 A2, still the same thing. So this expression and this expression are the same. So recall, but A all over Q, atomic mass all over charge. This is what we call chemical equivalent. Chemical equivalent of a metal. It's not the same thing as the chemical equivalent. We call it chemical equivalent. Please take note of that. And it's denoted by what? Z. So it's equals to atomic mass all over charge. Meaning Z is equals to atomic mass of an element all over charge. It carries all over charge. So definitely M1 all over M2 is equals to, this one will be Z1 all over Z2. It's not the same thing as electrochemical equivalent. We call it chemical equivalent is equals to atomic mass all over charge. This is another expression for Faraday's second law. So there are two expressions. This is the first expression in terms of number of mole and charge, and in terms of mass and chemical equivalence. You can see N1 is inversely, but mass is directly. From here you can say M is direct proportional to Z. But while N is inversely, this one is N is inverse proportional to charge. So this, so it can also be stated as so let's see. Faraday's second law of electrolysis states that if the same quantity of electricity is passed through solutions of two different electrolytes, the mass each metal substance deposited at the electrode cathode, and the electrode is directly proportional to the chemical equivalent of the substance. So we have defined in terms of mass and chemical equivalent. If you remember, mathematically, this one is given to M proportional to Z, where Z is equal to chemical equivalent. You can say M1 is equal to KZ1, that is equation 1. So M2 is equal to KZ2, that is equation 2, where K is a constant. Remember? So if you divide equation 2 by equation 1, equation 2 divided by equation 1, you are having M1 all over M2 is equal to KZ1 all over KZ2. You know, we have derived this. M1 all over M2 now is equal to Z1 all over Z2. That's another way of stating the second law of electrolysis. So there are two methods here. Formula. The first one, if you still remember, I say M1 over M2 is equal to Q2 all over Q1. This is the first formula. Faraday's second law of electrolysis. The second one is M1 over M2 is equals to Z1 all over Z2. This is the second formula. So these are the two mathematical expressions for Faraday's second law of electrolysis. I will say note. You want to find Z, where Z is equals to, we call it a chemical equivalent of a metal. Chemical equivalent of a metal. For example, and we said the formula for chemical equivalent is atomic mass, that is mass number, A all over charge. Q. That's the formula. So for example, e.g. copper, Z of copper, the atomic mass of copper is 63.5, while charge of copper is 2. You know, copper is 2 plus copper 2. So divided by 2. So whatever you get here, this is 31.775. That's the chemical equivalent of copper. Let's see for silver. Silver is 108. So divided by charge of silver is 1. So that's what we have, 108. Remember, silver is plus, while copper is 2 plus. Take note of that. Here's the charge plus 1, and so on and so forth. That's how to calculate chemical equivalent of a metal. Like let's see that of a sodium. Na. Sodium is 23, then plus 1. Charge is plus 1. So that will be 20, 23, and 80, etc. That's how to calculate chemical equivalent. So the next thing is to look at example. Mass of copper M1, 10.5 gram. That is solution. We have mass of silver is unknown. That's what you have to calculate. So in terms of mass, you know the formula chemical equivalent is equals to atomic mass all over charge. Atomic mass of copper is 3.5. So divided by 2, charge of copper is 2. So this one is 1.775. So Z2, that of silver, A2 all over charge 2. Silver is 108, charge of silver is 1. So 108. That is what we have. Then from Faraday's second law of electrolysis, we say that M1 all over M2 is equal to Z1 all over Z2. So M1 is 10.5, M2 I don't know you, Z1 is 31.75 over 108. So if you cross multiply, you have M2 straightforward, 10.5 times 108 divided by 31.75. So we are going to have 35.71 gram. That's the answer. This is the mass of copper. That is what we are going to do. That's the answer. We don't want to use this method. Another method of solving the question. Another method. Copper is a divalent metal element. So definitely 2 Faraday, 63.5 gram of copper will require 2 Faraday. Please take note of that. Which is equals to 2 times 96500 coulomb. Therefore, they mention 10.5 gram of copper. Let's see, we want to get the quantity of electricity part. So we require 10.5 times, we are using this 2 times 96500. 1 Faraday is equal to 965, so 2 Faraday will be 2 times. So divided by 63.5. So the answer 31913.39 coulomb. That is what we are going to have of electricity. So this is the quantity of electricity required to deposit 10.5. In Faraday's second law of electricity, if the same quantity of electricity is passed, that's what the law is saying. So for silver is monovalent. So 1 Faraday will deposit 108 gram of silver. That's the expression. We have done this one. That's for first law. 1 Faraday, because silver is monovalent. So it requires 1 Faraday to deposit 108 gram of silver. That is atomic mass of silver. So for that reason, I will say therefore, this 1 Faraday is same thing as 96500. So let me put it. Same thing as 1 Faraday is 96500 coulomb. Take note of that. We give you this. So therefore, 31913.3 coulomb, 39 coulomb. What would be the mass? So to be 31913.39 times 108, then divided by 96500. So whatever you get, that's the answer. So you are still going to get 35.71 gram. So the same answer as the first method. So you are going to get the same answer. You can use this method as well. You are going to get the same answer. That's the example. This is the question. So let's calculate the quantity of electricity passed first. Let's calculate the quantity of electricity passed. So let's see. Current is going to be 1.5 ampere. Time is 2 hours. 40 minutes is equals to 2 times 3600. That is 1 hour is equal to 3600 seconds. 1 plus 40 times 60, also in seconds. So I'll add the two together. 7200 plus 2400. So this one will be 9600 seconds. So that is our T. That's our T. Then our Q is equals to IT, which is equals to 1.5 times 9600. 9600. So is equals to 14400 coulomb. That's the quantity of electricity passed. Take note of that. So let's start with the first question. Let me see Roman figure 1. We want to how many grams of each of copper? Let's see that of copper. Copper, we say is divalent. So it will be 2 Faraday. That's 2 times 96500 coulomb of electricity required to deposit 64 grams of copper. So therefore, we want to look at 14400 coulomb. So it will be 14400 times 64, everything divided by 2 times 96500. That is in gram. In gram.
Mass deposited, mass copper deposited will therefore be 4.775 gram. So now we've got to let's calculate that of lead. So lead is a divalent metal as well. It's a divalent. That is 2 times 96500 coulomb of electricity is required to deposit 207 grams of lead. So therefore 14400 coulomb will be 14400 times 207, everything divided by 2 times 96500. So the mass deposited will be 15.444 possible gram of lead. So Roman figure 3. We want to see that of silver. Silver is a monovalent element. So 1 Faraday, 1 times 96500 coulomb is required to deposit 108 grams of silver. You know why this one here? Because it's a monovalent. Therefore, we want to see 14400 coulomb. So it will be 14400 and 108 divided by 96500. That is 1 times 96500. So when you divide it, you are going to get 16.11 gram of silver. This one of silver, this one of lead, while this one is a gram of copper. And you have gotten the mass of copper, call it M1. So mass of copper is gotten, let's say M1. Let's say Roman figure 2 now. We want to calculate the mass of lead. So we call it M2. That of lead is unknown. Then you look for Z1 of copper. Z1 of copper will be, remember, A1 all over Q1. Copper is given to be 64 all over 2. That is 32. Chemical equivalent. 3. Okay. So Z2 will be A2 all over Q2. So that of lead. Lead is given to be 207 atomic mass all over charge. Lead is also 2. So it will be 103.5. That's the chemical equivalent. Then you can use M1 all over M2 is equal to Z1 all over Z2. You can use this method. M1 is given to be 4.775. M2 is unknown. Z1 of copper is given to be 32. That of lead is given to be 103.5. So M2 straightforward will be 4.775 times 103.5 divided by 32. So M2 now will now be, you are going to get the same answer, 15.44 grams. So you can repeat the same thing for Roman figure 3. If you want to use Faraday's second law of electrolysis, let me complete it here. 3. So find Z3. Z3 is equals to A3 all over charge 3. A3, silver is 108 all over charge is 1, so it's 108. So you can use Z1, you can use mass 1 all over mass 3 is equals to Z1 over Z3. Mass 1 is given to be 4.775 divided by mass 3, we don't know, is equals to Z1 32 all over Z3. Z3 is 108. So N3 now will now be 4.775 times 108 then divided by 32. So we are going to get the same answer to be 16.11 gram. You are going to get 16.11 gram. That is what you are going to get. That's the answer. So the next thing is the last aspect. We call it applications of electrolysis. What are the applications of electrolysis? 1. We use it in the extraction of metals, e.g. aluminium, extraction of aluminium. 2. Purification of metal, e.g. copper. Take note under purification of metal. Impure copper is made the anode. Please take note of that. While the pure copper is the cathode. So the impure copper will dissolve in the solution and the copper will be deposited on the cathode as pure copper. The dimension of metal, the impure one, the anode, while the pure one is the cathode. Always take note of that. Using information of that. 3. Using electroplating of metal. Metal to be coated. The metal to be coated or the object to be coated is usually the cathode. while the method to be used for coating, is the anode, is made to be the anode. Please take note of that. Take note of that. Take note of that. For example, now you have copper, you have silver. You now want to coat silver on copper. So this is the object to be coated. You want to put silver on copper. So silver now will be the anode, while the object, that is the copper to be coated, will be the cathode. Please always take note of that. Take note of that. Then preparation, preparation of or production of some compounds, e.g., sodium chloride, used in the preparation of some gases, e.g., we have chlorine gas, and we have hydrogen gas too. This will mark the end of electrolysis. Please share, like, subscribe, and comment. God bless you as you do that.